We have the explanation of the photoelectric effect. Okay, explain the effect of frequency of incident radiation in the experiment of photoelectric effect. Now see, this figure shows the graph of variation of frequency of incident radiation at constant intensities. Now you are keeping the intensity same. Okay, intensity is kept same and you are changing the frequency. Okay, so intensity is constant, you are changing the frequency means you are taking different colored light, we can say in general. Okay, here frequencies are taken nu1, nu2 and nu3, and nu3 is the highest frequency. Okay, so they are in the increasing order. Okay, now for different frequencies of incident radiation, stopping potential value obtained by different but saturation current is found to be same. So the stopping potential, the potential which is required to stop the electric current is different, but the saturation current, that is maximum number of electrons which are emitted from photosensitive surface which are producing the electric current, and that is called the saturation current, is found to be same. So we can say if intensity is kept constant, the energy of the photoelectrons, if you increase the frequency, try to understand, if you increase the frequency, then the energy of the photoelectrons which are emitted from the photosensitive surface increases. Okay, from this it can be said that when frequency of incident radiation is more, then the energy, that is E is equal to h nu, okay, also will be more. Hence energy of photoelectron emitted will depend on the energy of incident radiation. When energy of the photoelectron is more, then more decelerating voltage, that is stopping potential, is required. So as energy of this photoelectron is more, you require more voltage or decelerating voltage or stopping potential is needed. For different metals, if graph of frequency of incident radiation and corresponding stopping potential is drawn, then it will be a straight line as shown in figure, or we can say as you increase the frequency of incident radiation, then the stopping potential also increases. So we can say that the energy of the photoelectrons which are emitted from the photosensitive surface increases with increase in the frequency of incident radiation. Okay, so graph gives you clear idea that for given photosensitive surface, stopping potential changes linearly with frequency. For given minimum cutoff frequency nu 0, stopping potential will be 0. Okay, stopping potential is 0 for given what you call it, the cutoff frequency. That minimum frequency, cutoff frequency or threshold frequency is the minimum frequency that is required to produce the photoelectron, and for that nu 0 the stopping potential is 0. Okay, the above observation suggests that maximum kinetic energy of photoelectron changes linearly with frequency. More the frequency, more the kinetic energy, but it does not depend on intensity. Try to understand, we have in our classical physics, more intensity means more energy. Okay, and here it has been contradicted that more the frequency of incident radiation, more the kinetic energy of the photoelectron which is emitted. Okay, when frequency of incident radiation is less than cutoff frequency, the photoelectric emission will not take place for any large value of intensity. If you are not having the proper frequency, or we can say more than the frequency of cutoff value, then there will be no photoelectrons are emitted. Try to understand, you require a minimum frequency for the emission of the electron. If you keep very high intensity but your frequency of incident radiation is not more than the cutoff frequency or threshold frequency, there will not be any photoelectrons emitted from the photosensitive surface. Okay. Now there are certain characteristics of photoelectric effect for given photosensitive substance, that is the photosensitive surface, we can say, when frequency of incident radiation is greater than the threshold frequency, photoelectric current is proportional to intensity of incident radiation. So the incident frequency has to be more than the threshold frequency, then and then the photoelectrons which are emitted will be increasing with increase in the intensity. Try to understand. For given photosensitive substance and frequency of incident radiation, saturation current is proportional to intensity of radiation, but stopping potential is independent of intensity. More the intensity, then more the number of photoelectrons emitted from the photosensitive surface. Okay, so we can say that saturation current is proportional to intensity, but more the intensity does not mean that more the stopping potential. Okay. For given photosensitive substance, if frequency is less than threshold frequency, then there will be no photoelectrons emitted. Okay, so there must be a higher value of frequency, or it must be equal to the threshold frequency. Okay, if you keep very high intensity and the frequency is less than the threshold frequency, then there will be no, or there will not be any photoelectrons emitted from the surface. Okay, photoelectric emission is independent of intensity of radiation. It is instantaneous. Okay, photoelectrons are emitted instantaneously. Okay, it takes very small interval of time, that is 10 to the power minus 9 second or less, to come out if frequency is proper, or we can say it is equal to or more than the frequency, that is a threshold or cutoff frequency. Okay. Now see, our conventional wave theory cannot explain this photoelectric effect or fundamental characteristics of this photoelectric effect. How? Then we have light is electromagnetic wave which are made up of electric and magnetic field. Phenomena like interference, diffraction and polarization can be explained satisfactorily with the help of this wave theory. According to wave picture of light, okay, when light is incident on surface of metal, free electron will absorb the radiant energy continuously. That is, absorption of energy is done by the electrons. That is the main assumption. When intensity of incident radiation increases, amplitude of electric and magnetic field will also increase. Okay. Hence, more energy will be absorbed by the electron. That is our assumption, that is our conviction here. Okay. In our wave theory, more the intensity, then there will be amplitude of electric and magnetic field will increase. Okay. And what will happen? More energy will be absorbed by the electron. According to this, maximum kinetic energy of electron on surface should increase with increase in intensity of light. Okay. A sufficient intense beam of any frequency should be able to impart enough energy to electrons so that they exceed minimum energy needed to escape from the metal surface. Now, if we have very high intensity radiation, irrespective of frequency can be any, but if you have very high intensity of radiation, then according to wave theory, this radiation should be able to make the electron escape from the metal surface, or it will provide the minimum energy which is required to make the electron escape from the metal surface. Okay. Threshold frequency therefore should not exist according to this wave theory. Now these expectation of wave theory are contradictory here in this experimental results of this photoelectric effect. According to wave theory, absorption of energy by electron take place continuously over entire wavefront of the radiation. So slowly the electron will acquire the energy and then it will come out of the photosensitive surface. Okay, so it takes some time to acquire the energy as very large number of electron absorb the energy. Energy absorbed per electron will be very less. Now electrons are many in the surface and they will all acquire or they will all absorb the energy. So this energy absorbed per electron will be very less. Now calculation estimate that it can take hours for an electron to come out from the metal surface. While here if the proper frequency radiation is incident, then it is seen in the photoelectric effect that within 10 raised to minus 9 second or the time less than this, the photoelectrons are coming out. Okay, thus wave theory was unable to explain the basic feature of the photoelectric effect. Now there is an Einstein's explanation for this photoelectric effect. He gave this explanation in 1905. According to this theory, not only emission but absorption of energy, that is called the photon, also takes place in discrete unit. Absorption of energy is also in the discrete unit, in the quanta we can say. This unit are called the quanta of energy of radiation. Each quantum, that is called the photon, that quanta of energy is known as the photon, has energy which is equal to h nu, where nu is the frequency of radiation, h is the Planck's constant. Okay, so energy on the surface will be equal to h nu, which is absorbed. If energy absorbed by electron on surface is more than minimum energy, that is called the work function. If this energy h nu is more than the work function, okay, then electron will be emitted from the photosensitive surface with the maximum kinetic energy. Okay, let energy of incident radiation is h nu. We consider that nu is the frequency of the incident radiation, then the energy of the incident radiation is h nu. This will be the energy. And maximum kinetic energy we take as k max and work function as phi 0. Then we can say that phi 0 is nothing but minimum energy required. Okay, phi 0 is minimum energy required, which is equal to h nu 0, where nu 0 is the cutoff frequency or threshold frequency. Now if you are incidenting the energy h nu more than h nu 0, then h nu, okay, is equal to maximum kinetic energy plus the threshold, or we can say minimum energy required, and that is nothing but the work function. So k max is equal to h nu minus phi 0. More tightly bound electrons will emerge with kinetic energy less than the maximum value. Some electrons are there in the metal which are more tightly bound. They will not have this maximum kinetic energy. With increase in intensity of light, number of electrons emitted per second will increase because more photons are incident per unit time. However, maximum kinetic energy of the electron emitted is determined by the energy of photon. In Einstein's equation, maximum kinetic energy K max, that maximum kinetic energy is equal to EV0, where V0 is the potential, that is stopping potential. So K max, instead of K max we write EV0, because maximum energy of the particular electron will be K max, and that will be equal to EV0. Up to that V0 is stopping potential. Okay, so maximum energy of the electron which is coming out is EV0, and that must be equal to kmax. Up to that, the maximum kinetic energy can reach. So EV0 is equal to h nu minus phi 0. Here, graph of energy versus frequency is found to be straight line. Okay, and if you make V0 as subject of formula in this equation, okay, make V0 as subject of formula, then E will come in the denominator of both these terms. Okay, so it becomes h upon E into nu minus phi 0 upon E, and slope of this graph of V0 versus frequency is found to be h upon E. This does not depend on type of matter used. Okay, as h upon E is the constant for any photosensitive surface. So this graph is of V0 versus nu. Einstein's equation suggests that for photoelectric emission, when energy is incident, or we can say energy of incident radiation should be more than the work function. Okay, so if you are incidenting the energy of the radiation which is incident is h nu, this is the energy of incident radiation, must be more than the work function. So kmax is equal to h nu minus phi 0. Kmax should not be negative. Okay, phi 0 is equal to h nu 0. Okay, so nu 0 can be found as phi 0, that is work function upon h. This equation suggests that more is work function, frequency nu 0 corresponding to minimum energy will be more. More the work function, more the energy, that is nu 0, or we can say more the frequency, rather more the work function, more the frequency. No matter how intense is the radiation frequency of incident. Okay, if you have a very intense light, okay, radiation should be having the frequency which is larger than the threshold frequency. Your light is very intense, but if the frequency is not more than the threshold frequency, then what will happen? The electrons will not come out of the metal surface. Okay, thank you very much. Try to see this video and understand the topic.